Hi, today I'd like to talk about iterators. Iterators are extremely powerful concepts that you need to learn in order to write idiomatic Rust code. In this episode I will show you how to implement your own iterator. Let us take a look at the declaration of iterator thread in standard library. We see a lot of different methods, but what is cool about iterators is that we need to implement all in one of them. It's the next. And all of others we are just getting for free because they already have default implementation. So what we need to implement is some method next that returns optional item, and also we need to define associated type item, just the type of value that our iterators will return. You may ask yourself why you should bother about implementing your own iterators. Pretty fair question. There are a lot of iterators that come from standard library, and in most cases you will use them or will use some others that come from other libraries, but there are some particular cases when actually you need to implement your own. For example, when you are working on some libraries that provide some iterator. I come up with some examples where iterators can be used. For example, you can implement iterator that generates some sequence of numbers or characters, like, let's say, Fibonacci numbers or prime numbers. Of course, there are already some solutions for this, but it's just an example. There's a case when you need to traverse some data structure, for example, JSON or XML, and you want to produce some values depending on some filters, something like that. Another example, just traversing a file system. Or let's say you want to use some remote API with pagination and you want to iterate through items, but under the hood of your iterator you may use pagination API. Initially, I wanted to make this episode with an example of iterator that produces Fibonacci sequence, but it's already implemented in Rust by example, and I would recommend you to take a look just to get some basic feeling how simple iterator looks like. So I decided to come up with artificial problem, but it have some real-life challenges, so it may be probably more useful for you. And the problem sounds like the following. Implement an iterator that traverses vector of integers and produces those items which follow an odd number. And here's an example. If we have the following vector, we expect our iterator to produce number 6, 1, 9, and 0. Just because they follow in odd numbers in this sequence. Okay, now comes the fun part. Here I have main program with a little setup, the vector that we had in example iterator, and some assertion that verifies correctness of iterator implementation. Now let's implement our iterator. So it will be some sort of structure that needs to hold the vector of type, let's say, U32, and probably some index if we need to iterate over the vector. Now let's implement new method. And now we have to implement iterator trait. So here we have to define type item. Type item. In our case it will be u32, just the same value that holds the vector. And next method. So here in this case self item is, and its reference to u, it's just the same as u32. Okay, I can implement the simple naive implementation just to make the program compilable. Okay, I have to define the index here as well. Let's make it 0 by default. Yeah, so at this moment we have programs that compiles but doesn't really work, so it doesn't really iterate. At this point I will keep it simple and will just use while to iterate over vector values. Now here we're gonna obtain previous value and increment the index. And now we actually can add conditions that will verify is previous value odd or no. So if previous value is odd, then we're going to return the current value. So cool, so far it compiles and even works as expected. Now let's try to improve it. So what if I want to use vector here? Just let's say I want to print it out. Sorry, I want to debug it. Yeah, we cannot use it because actually Iterator consumed it, and now ownership of the vector was given to Iterator. So it wouldn't be bad if we could pass it as reference instead of just vector. Let's pass reference to vector, or more precisely slice. So I'm going to rework Iterator a little bit. Now we have to make Iterator generic over lifetime A, because we want to pass reference. We want our Iterator to keep reference to the vector. And eventually we have to pass reference instead of vector. So as you saw, we have to change definition of iterator and pass lifetime in every implementation. A little bit of boilerplate. Yeah. But now we are able to use our vector. I want to remove this and use for loop in order to iterate over iterator, just like this. I forgot a comma. Okay, so what else we can improve here? Let's say we want to make our iterator even a little bit more generic and to pass this condition dynamically. So for this we would need to somehow to make our our iter structure to contain closure of function that implements this condition. Let's define it here. It will be box because all closures, just in order to store closure in structure, you have to box it, because usually size of closure is not known. But this closure have to implement trait fn, which means just basically closure of function. Function that takes user2 type, because it's type that we keep in our vector, and produce boolean, return boolean. Okay. Now, probably as temporary solution, I will implement a function condition here. Just does exactly the same. I mean, it will be our first thing that we'll save in our iterator. Now let us implement some simple function that matches this signature. I call it condition. And it will be something that will pass to when we initialize iterator. Yeah, I just did it to make compiler happy, just with little baby steps. I will replace it completely. Okay. Now let's try to pass actual closure here. Of course, for this we need to define it in our new method. And it's something that have to be generic. So we want method new be generic, that accepts function with type f, and this type f must implement exactly the same trait as here. I'll just copy it. So with this we just saying that we want f be something like function or closure that implements trait fn. Okay, so it compiles. It's pretty good. Now let's try to replace our static function with actual closure here. Yeah, we're getting this error, and compiler recommends us to add static. We'll try to do it. So it compiles, and now we can just safely remove this function. Yeah, it compiles and we still have the same result as previously. It's pretty good, I would say. And we actually now can play with this, and let's say we want the condition be all numbers that can be divided by 3. Doesn't work. Yeah, it doesn't work because we haven't replaced actual condition here. So let's try to do it. I'll go self, then f, and then I'll pass previous value to this function. And again, it doesn't compile, and just compiler says if we want to use function stored in f field, we need to use braces. Now we're getting the result as expected. So we have 7 and the sine is 6, which is divided by 3. Then 9 is divided by 3, so we got 0. And we have 3 because actually, by this logic, if we divide by model, 0 is also can be divided by 3. And the final thing that I'd like to do in this episode is try to make iter structure even more generic, to be generic over type of vector. So let's replace all u32 with the generic type t. And now, of course, I have to define t here. You see, there are a lot of places we have to change our type. It's something that is not that fun so far. And we also have to specify that our type t has some lifetime, let it be a. And now we're getting this error that actually we cannot move value out of vector. And so previously we had u32 type, and now that has the implemented copy trait, and now we're using t that doesn't guarantee to implement copy, so we just cannot take values out of vector like we do here in this line. And to fix this, I just want to specify one more constraint for type t. I want to say that all t that implements trait copy. And now it works as expected, so we're still getting the same result, but now we can use other types like U32, let's say, or U8. So now our iterator is agnostic about type of vector. And yeah, it's possible to go one step further and actually to make iterator return not type T but reference to T. But you can do it yourself as a homework. That's it for today, and thank you for watching, guys. And thanks for your comment, I really need your support. It takes a lot of time to produce these episodes, and yeah, thank you.